What's up? What's up? It's your man Jimmy Chan. All right, so I have a gutter that is made of from sheets of aluminum that are 18 inches wide. By turning up the edges to form right angles. So let's take a look. So I have a sheet here that's 18 inches. Okay, meaning from here to here, that's 18 inches. Okay, so that's what it's trying to say. There we go. Okay, so from there to there is 18 inches. So let's take, for example, that I take this, and what I'm going to do is I'm going to go ahead and I'm going to go ahead and crease this corner right here and put it up, and crease this corner right here and put it up. Okay, so in other words, this part right here is now to here, and this part right here is to here. Okay, so, and if I was to, I guess, put it in like stages, I would say that would go something like this, right? So this is the final stage, but the stage before that would be something like this. Right? So I'm creasing it and then folding it up. So it goes from this piece to this piece, and then that piece to that piece. Okay? So what you have here is that you have the depth of the gutter, which is the same as this depth of the gutter, and this would be now the width of the gutter, right? So the 18 inches is really this piece here, right? It would look like this. It looks, oh, sorry. That should have been blue. It looks something like that, right? So as I fold it up, so still the 18 inches is all of those together. So my 18 inches is going to equal to my depth plus my width plus my depth. So I have 18 is equal to 2D plus W. Now, what it wants to maximize, however, is the cross-sectional area. The cross-sectional area is this piece right here. Okay, so this right here, let me see if I can do something here. All right, so that is the cross-section area right there. Okay, so if I could make it a little bit smaller, which I don't know if I can or not. Well, no, you know what I'm gonna do? Can I send this to the back? I guess not. Okay, that's certainly fine. So remember that I had this side. I had this side, which was the width, and I had this side, right? So those are, so this purple is my cross-section area. Well, what is the formula for area? Well, area is gonna be my base times height, right? That's how I know area. Well, the base here is my W. And my height here is my depth. Either the blue or the red, doesn't really matter. All right? So, and it wants me to maximize the area. Okay? So it wants me to maximize the area, so that means I have to keep the area formula. So with the area formula, what I would need to do is take this 18 equals 2D plus W and put it in here. So what I can do is get the W by itself, and that would equal to 18 minus 2D. So I'll put that in here. So therefore, my area is going to equal to 18 minus 2D times D. Okay, so in that case, my area formula, A of D, is equal to 18D minus 2D squared. With that being said, what I actually need to do is I need to find, so again, this would be in standard form. So in standard form, I have to find the axis of symmetry first, okay? Because what I do know, since my square term, the coefficient is negative, I know that this is going to be a frowny face, okay? So that means I need to find my maximum here, which is my vertex, but in order to do that, I have to find my axis of symmetry, okay? So my axis of symmetry is equal to, D is equal to negative B over 2A. Well, that would be D is equal to negative B, which is negative 18, divided by 2 times negative 2, which gives me 9/2, which is giving me 4.5, which is my D. So in other words, up here, D here is equal to 4.5, and this D is 4.5. And if you notice, what does the question ask for? The question asks for to determine the depth of the gutter. And I have just found the depth of the gutter, which is right here. And that, ladies and gentlemen, is choice A. Well, I hope that helps. If there's any questions, let me know. See ya. Bye. And this shouldn't be any fill anymore. No fill. There we go. That's much better. See ya.